Okay, we've talked about the fact that you cannot directly observe consciousness because it is a psychological construct. But what we can do is look at physiological responses and try and determine consciousness from those. So there are four main methods to study consciousness. There's the measurement of physiological responses, measurement of performance on cognitive tasks, where you get someone to do an activity and then you see how well they've done that activity. Self-reports, where the person tells you how conscious they are. And then video monitoring, so directly observing what they're doing. Today we're looking at measurement of physiological responses. So the idea of this is it's collecting data on bodily changes and responses at various states of consciousness. And we're going to be looking at the three most common measurements. The electroencephalograph, or EEG, you may have heard of before. The electromyograph, also known as an EMG. And the electrooculograph, the EOG. Now today's lesson we're just going to be looking at the electroencephalograph, the EEG, and next session we'll look at the electromyograph and the electrooculograph. So the electroencephalograph, we break that word down. Electro, electricity. Cepha, you may remember when we've looked at the brain before, ceph actually refers to the brain. And a graph is an image. So essentially what we're doing is we're looking at electrical activity of the brain in an image. Now you need to know this definition. An electroencephalograph, or EEG, is a device that detects, amplifies, and records patterns of electrical activity over time. Most important part of this, you never write EEG without writing electroencephalograph first and then putting EEG in brackets. When you write the definition, it must state that it detects, amplifies, and records electrical activity. Now I've put those in italics to remind you. Detects, amplifies, records electrical activity. So what does it do? Basically we get these little small electrodes that you can see in this picture here, and they're attached to the scalp through a head cap. So in this example here, this would be through a head cap. Sometimes they attach them directly to the scalp, and they detect the electrical activity from the neurons in the cerebral cortex, and they can pick it up through the skull. The EEG, so the machine that does this, then amplifies. Amplifies means to make it bigger. So that little electrical activity is very tiny, so we make it bigger so we can see it, and we translate it into a visual pattern of brainwaves. And that's what you get here, this EEG reading, which we call an electroencephalogram. And these readings are what we call our brainwaves. The rate, height, and length of brainwaves varies, and it changes person to person, the area of the brain, your age, your state of consciousness, they all have an impact. But we can compare individuals using a standard procedure. It's called the 10-20 system, and it's about the placement of those electrodes. The main thing you need to know from this is that when we're comparing them, we're looking at the amplitude and frequency of a brainwave. What are these things? Well, amplitude is how high the peaks and troughs of the brainwave is. So a high amplitude brainwave has high peaks and troughs. It's going right up and right down, right up and right down. A low amplitude brainwave would have short peaks and troughs. It goes up and down, just small amounts. Frequency is the number of brainwaves per second. So high frequency means there's lots of brainwaves per second. So there's lots of them really close together. And low frequency is very few brainwaves per second. So there's very big ones in terms of long waves. So let's have a look at this picture here. High amplitude goes up really high, goes down really low. Low amplitude only goes up a little bit, down a little bit, up a little bit, down a little bit. Frequency. You see, these electroencephalograms are a measurement over time. So you might say that from here to here is 1 second. So high frequency means we have lots of brain waves in that 1 second, whereas low frequency might only have 1 or 2 brain waves in that second. So you're looking at the x-axis here being time, and your y-axis is electrical activity. All right, some brain waves we need to know. The first one is your beta waves. And this is what's going on, or the type of waves you'll experience when you are alert and in an intensive mental activity while in normal waking consciousness. They have high frequency, so lots of them, with low amplitude. So they're not going very high, they're quite small. Alpha waves, these are the waves you get when you're awake and alert, but possibly not particularly mentally or physically active. So you're relaxed, maybe internally focused. And this is high frequency. So again, there is quite a lot of waves in a short amount of space. But as you can see, compared to beta, it is slower, but we still consider this to be high frequency. It is also low amplitude, so it's not going up very high. However, it is bigger, as you can see, than beta. The next one we need to know is the theta waves. And this is what happens when you start getting drowsy, just when you're falling asleep or when you're waking up. This has a medium frequency. So it's quite a few per second, but not a lot. And as you can see here, it's a mix of high and low amplitude. So here you can see there's some low amplitude, and then you'll get some high ones. They'll go low, and then you'll get high. You've got delta waves. And this is associated with deep dreamless or unconsciousness. All right, low frequency. There's hardly any waves per second here. And high amplitude. So it's hard to see this in comparison to the others, but it goes right down and right up. All right, D for deep sleep. And to remember the order from most aware and active to least aware and active is BAT D. So beta, alpha, theta, delta, Greek letters. And here you can see them in comparison to one another. So you can see here that really high frequency, still a relatively high frequency, however, a little bit less than beta. Then we're getting to that medium frequency, and then that big long waves, low frequency. Here you can see the amplitude very tiny, still quite small, and then we're getting small, followed by really big ones, and these are really long. Now, if you want any more information, I have included a link, and you can have a look at those brainwaves in more detail if that's what you're wanting to do. All right, enjoy the activities.